All right, guys. Now I want to show you guys all how to use a motor controller and your Prizm Cortex to control one of these VEX 393 motors. We tried earlier using the continuous rotational servo port. It isn't really supplying enough power to get these motors to run consistently. It was burning out the motor speed controllers. So using one of these motor controllers is actually going to be a pretty simple solution to using these heavier duty motors. Now if you're just using a traditional servo, please use the servo ports here, but if you're trying to use a motor, we're going to use a motor controller. So a motor controller is just a device that lets you supply an input voltage, any input voltage. It could be a 9-volt battery, a 12-volt battery, it could be something else, and it lets you control two motors. So there's two sets of connectors on either side of this motor controller, so we can plug in and control two separate motors. So again, the idea is that we can now use an external power supply to supply this motors rather than trying to use like the 5-volt output on the board. I want to make sure my battery's turned off before I start hooking this stuff up. I'm going to plug in my battery for my Prizm here, and I'm going to use this other battery port to power my motor. Now you probably already have these motor ports down here occupied. I mean, these have built-in motor controllers that let you control motor 1 and motor 2 on your Prizm, and there's code and stuff for you guys to do that in the Prizm library. Here we're trying to use additional motors. So I've actually got these little power wires wired up. So let me plug these into my let me plug these into that open battery port. And I'm going to plug these wires into the power supply for the motor controller. It's these three inputs here. You'll notice they are labeled along the bottom. Ground is always the middle one. We want to make sure we're plugging up our 12-volt battery to the plus 12-volt pin. And so that's going to look something like this. Now, you can also use these motor controllers if you're trying to power a motor using just like a traditional Arduino. Like Tetrix makes expansions for their motor controllers where you can hook up more motors. They run about $100. You can pick up one of these motor controllers for a couple bucks off of Amazon. They are relatively cheap. So I'm just going to flip this on. Hey, there the light comes on. So that tells me I got power to my motor controller. Now, I'm going to use the set of connectors over here. It corresponds with out 1, out 2 labeled on the printed circuit board. Now, it doesn't really matter what direction I plug these wires in. Changing the polarity for my DC motor will just change the direction that the motor is spinning. So I'm going to plug it up so that the red wire, the positive side, is at out 1. All right, so if I turn that on, that should supply power to my motor. Now, I actually got to be able to turn the motor on and off as well as reverse the direction for the motor. So we're building these robotic arms. We need these actuators to be able to move one direction and then move the other direction. And so to actually, switch that off, to actually control what's happening with this motor, I'm going to use these little pins sticking out here right next to the power bank. And looking at my Prizm, there's these little white JST connectors. They're labeled I2C, A1, A2, A3. We're going to use D4. They've actually got some built-in digital pins. I mean, they're built so that you can just plug in a sensor to them. And so most of these have like a plus 5-volt, a ground pin, and the other two pins are typically the digital input pins that you'd find on like a traditional Arduino. So if you remember doing that with the Arduino stuff, this should be a piece of cake. I'm going to plug in, I got just a JST connector here. Push that in, make sure it's pushed down all the way. And I mashed my wires, so hopefully that doesn't hurt things too much. Now we're not going to use these two because we don't need to supply power. We are going to use the yellow and white wires here because those are going to correspond to, I believe, digital pin 2 and digital pin 9 on your traditional Arduino. So if you're coding this using the Arduino IDE, should correspond to pin 2 and pin 9. So let's switch over to Arduino and see if we can get some code working to get our motors turning. All right, I'm going to use the preprocessor defines to assign my pins. And so the way they're labeled on the circuit board is typically input 1, input 2, input 3, input 4, corresponding to like output 1, output 2, output 3, output 4. So let's do that. I'm going to say M for motor in 1. That should be pin 2. Let me do the same thing for the other motor. So motor input 2, and that'll be digital pin 9 on my Arduino. Let's do my pin setup. Pin mode. So motor in 1 is going to be an output. Motor in 2 is going to be an output for my board as well. If you want to use the other digital pins from the Arduino using these connectors on your Prizm, you'll have to look at the Prizm handbook to figure out what those pin assignments are. But as far as actually like enabling this motor and letting it turn on and off, it's actually pretty simple. If you use a digital write, and let's write a high signal to the first motor control pin. That should turn my motor on. Now I got 2 pins here I'm trying to supply a value to, and so the way this works, if one of them is high and one of those pins is low, then my motor will spin one direction. If I switch the low and high, it should spin the other direction. But let's just test out this code, see if this code works. This should turn my motor in one direction. Only if I turn it on. My wires are a little bit loose, but there's my motor spinning. All right, easy enough. Now, to get my robotic arm to work, I want to be able to move this motor in both directions. So to do that, I'm going to put a delay in here and set up another set of digital writes. Now, if I set both of these digital writes for input 1 and input 2 to low, that's going to turn off the motor altogether. So let me digital write low. Add another delay in here. And so if I upload this code to my board, that should turn my motor on, rotate it one direction for 1 second, and then that should turn it off. Except that's set to 100 milliseconds instead of 1 second. So that's being super slow. Okay, if I want to switch the direction that the motor is turning, I need to put in my digital write. Almost the same thing, except slightly different. Actually, let me just go up here and change that. I'm going to change this low, high. So just changing the order of which one's low, which one's high. If I upload that to my board, yeah, we'll see the motors now spinning in the opposite direction. So that should be enough to actually control this guy. If you want to control the speed that the motor's rotating in, it's a little more complicated, and I'll be happy to show you how in class.